Now, a client will be submitting, all the clients will be talking to the resource manager, and resource manager will be talking to the node manager. And each of the node is having a node manager, right? Each of the node is having a node manager. So node manager will say how much of resources available on each of the node. Okay, let's say this guy is a delivery manager. Okay, and under him there are 3 teams, and each team is having their own project manager, and this project manager is responsible to handle the project related capacity, right? So if a delivery manager has to ensure that I want to get a new delivery done, so he has to be in a continuous sync with all the project managers to find out how much of capacity does their team has, right? So similar to that, this resource manager will always have to be talking to the node manager to find out their capacity, available capacity, how much of the new task they can take. And node manager will be responsible to continuously tell them, okay, this much of capacity I have, this much of capacity I have, right? So that's how they do the resource management. Now, any new task which comes up, any new job which comes up, it will be given directly to, so each job will get its own application master. So let's say there are 2 jobs. One client came, this client, this client came and he said, okay, I want to run some job. So what this resource manager will do, it will start a application master for it. Over here, it started an application master for this client, or this job. Okay, some another job request came, so he will start another application master for another job. So like this, all the intake job will get their own respective application master. Okay, these application master are responsible to handle their own job, not, so this application master will not bother about the application which is run by over here. It will only deal with its own task. And how it will deal, let's say for running this job it needs some resources, right? So it will need some resources, then what he will do is he will ask, okay, I need this much of resources. Then he will negotiate with the resource manager saying, okay, you give me uh, 1 container or 2 container, right? Container is nothing but a space where the task will be executed, right? It will have some CPU, some RAM, all those type of things. So this guy will negotiate with the resource manager, okay, give me 1 container or 2 container, and then those container will be allocated to them, and this application master is responsible to execute its task into the containers. So say for example, this was a small task, so it was only 1 container was sufficient for it. It started 1 container and it's happy with it. Say this application master, so it need more resources, right? So if it need more resource, it started 3 container, container 1 over here, container 2, and container 3. Now if you look into this diagram, it's not necessary that the container will be given on the same node where the master is running, right? It can be started anywhere in the cluster. Whoever has the resource available, they can start it. It's just like if your project manager is sitting in Hyderabad, you might have a resource present in Bangalore or in Chennai or Pune, anywhere, right? So so this project manager will be responsible to coordinate with all the resource and ensure all the tasks are done by a distributed team. Okay, so in this architecture, the major advantage is the scalability, because we have broken down the responsibilities to multiple processes, right? So with the help of this new architecture, the scalability of the cluster can be increased from 6,000 to 10,000 machines easily, which was limited to only 4,000 in Hadoop 1, right? With some changes in the architecture, the scalability has been increased to many times, right? And each machine can be very huge amount of, like all the big machines, and there can be 100,000 concurrent tasks and more than thousands of concurrent jobs running all together. So which means the capacity or the resource utilization of the cluster has been increased. The number of task which can run in parallel has been increased. The entire bandwidth of the cluster has been increased, right, by just changing the some of the limitations or by changing some of the architectural thing that were the limitations of Hadoop 1. Is this clear? Any questions on it?
Since we have already node manager, still do we need app manager? Node manager cannot fulfill the app manager's role over there.
No. Node manager is responsible only for the resource management, right? Because it will only take care of how much of CPU resources are required, how much of things are free, and it will tell to this resource manager saying this much is free. So node manager cannot act as application master. Both has to be different.
What if the resource manager fails here?
Wonderful question. So if a resource manager fails, then that's a risk, right? Because we have only one resource manager. But since with the new Hadoop 2, there we have a concept of high availability, right? So if we have a high availability for name node, why we cannot have a high availability for the resource manager, right? So to answer your question, the answer is even the resource manager can be made highly available. So instead of one resource manager, we can have two resource manager, and that's what happens. So in all the practical production environments or any practical distributions, they don't go with one resource manager. They go with two resource manager in a highly available state. Any other questions?
And is it HDFS?
Could you repeat, please? Your voice was breaking.
The yarn, is it the part of HDFS?
Yarn is not
Does
part
this
of the HDFS. No, it is not part of the HDFS. It is not part of HDFS.
okay? That
Yeah, it's
so
different.
it works over HDFS, right?
Absolutely, it works
We
over.
can say it's a layer above the HDFS.
Yes. So HDFS is a storage part, and yarn is mostly about the processing part of it, right? So HDFS deals with the storage, and yarn deals with the processing of the data.
Okay, Dheeraj, thank you.
There's one question. Suppose one task or one job required probably like a 2 GB of RAM. Okay. At the time allocations, it's taking some 2 GB and allocating for the job to execute. Suppose if you have a shortage of what you can say the resource, what will happen? Will it keep waiting for that, or will it handshake to some other what you can app manager to execute that process?
Yeah, so if there is a shortage, what will happen is this app master will negotiate with this, and it will start another container, and it will start working in the another container. So it will start another container which have some more CPU or whatever resources.
Okay, so it has intelligence to further divide and execute the job.
Yes.
Okay.
Okay.
What is that map reduce status?
What is the map to details?
Status. In the arrow mark, it is shown as map reduce status, right? What is that?
Map reduce status. Where can you see that?
In the bottom.
Map reduce status. Oh, okay. So see, map reduce status is nothing but these processes what they are running. They are running. This containers will be actually running the map reduce jobs. Okay. So MapReduce status is represented with a solid line, right? So this container is running some MapReduce job, and they have to tell the status of that to their master, right? Whether that MapReduce job is successful or it failed, or what is the status of that, right? So any task execution has to be reported back to the master, which is application master. So you submitted a job, a MapReduce job, you got a master for it, and that job has 5 tasks, or let's say 10 tasks. So those 10 tasks, status of them has to communicate back to the master saying what really happened to your all the tasks that were started, right? So that's what is represented with this solid line. And if you look over here, this one is the node status, right? So these blue dots, they are representing the node status. So node manager will report the status to the resource manager saying what is the status of the data nodes. Okay. And if you look over here, resource request is represented with this one, right? So this app master will request the resource manager saying, okay, I want 3 containers, this much of resources, right? So based on that, those containers will be allocated to the application master. Right. So let's come back to this. So that's what we have, right? So in earlier version, like before 2012, so this yarn and all, it came in 2012, right? And after that, all of these changes started. So before that, the only thing which Hadoop 1 could process was only MapReduce job. Like it was not able to do anything else. But with the introduction of this yarn, some non-MapReduce job can also be processed. So MapReduce, definitely it can be processed, but there are some other data processing things like Spark and Storm, right? Giraffe. So a lot of new data execution models, they can also be run on the yarn, using the yarn. Okay, that's another advantage of using yarn. Okay, so Yahoo was one of the largest contributor to, because yesterday we show, like, so Yahoo, with the help of dog cutting, they started this entire journey of the Hadoop. So Yahoo has made a lot of investment and a lot of projects which runs on the Hadoop, right? And in the late because when whatever Yahoo and the team developed, it was Hadoop 1, which has some limitations, right? So after the yarn came into picture, so Yahoo also adopted it to a very large scale to start a lot of Spark, Storm, this type of workloads. And not only this, what I see today is I don't see a single usage of Hadoop 1 nowadays. So everybody has migrated to Hadoop 2, considering all the benefits that they have, and almost all the companies, whoever is having Hadoop, everything is on Hadoop 2, which is on the yarn. Right, so there's nothing called Hadoop 1 which exists now anymore. Okay, so there's so many advantages of yarn, as we saw, like, so we came out with the bottleneck of the resource constraint. We made it more scalable, more robust. We made it more efficient utilization of the resource. A lot of advantages that we have over the classical MapReduce. So let's talk about some of the detailed. So it's the same discussion that we saw, right? So uh, application master will be there and will start the containers and all of this. Let's quickly go to scheduler. Okay, let's quickly go to scheduler. So application manager, as we said, like, so it starts with a scheduler. So what happens, scheduler is responsible for allocating the resources. So in this slide we show, like, there's application manager, right? So there has to be a scheduler who has to go and talk to. So scheduler is something where it's responsible to track the status of the application and whether it failed, restarted, and all of that. And there are different types of the scheduler, like capacity scheduler and fair scheduler, which which Yarn provides. Right, so scheduler is nothing like how you are scheduling your task. Right, so like first in first out is one of the scheduler. So what will happen if there are some jobs which are in the queue, right? So it's the normal OS. Let me give you a brief about the schedulers. So there are three types of schedulers: first in first out, and there is a fair, and there is capacity. Okay, so first in first out says like if it's a simple like a queue, right? So whoever comes first, that will be processed first. Now can you tell me what is the problem with the first in first out? Anyone problem with the first in first out scheduler?
Dheeraj, about the priority, maybe, some process which is coming later, maybe, having higher priority or something.
Right, so that's the challenge, right? If let's say I have a job one which takes, say for example, it is taking 100 minutes. Okay, it came first, and I have a job two which needs 2 minutes, right? So since this came first, to process my job two, I have to wait for 102 minutes because it won't start unless this one completes. That's the biggest disadvantage of first in first out, right? And then there comes a fair, which will give a fair amount of resources to all the jobs, so which means like it's kind of distributed among all, so everyone will get a fair amount of jobs, right? And third one is a capacity, so where you can customize, you can decide some priority, and you can put some weightage to your some of the queues. You can have different queues, right? You can say like, okay, in this I have 5 queues. One queue is for sales jobs, one queue is for HR jobs, one queue is for analytical job. You can create different queues, and you can set some priority. So based on the priority, it will assign the resources in capacity, right? So these are the high level schedulers definition, different types of the scheduler. Okay, so if you have a very large cluster, you have to go with the capacity. Usually this is what is used in the companies, in the industries, in a real time. They go with the capacity because it gives you more control, right? You can decide which project should be given what sort of priority and all. So all that advantages we have in the capacity. First in and first out, I don't think anybody even go with this. It's just there. Fair can be used for some small silos. You are starting a POC kind of a cluster with some 5 nodes or 7 nodes. You don't want to deal with all of this. You don't care for all of these things, right? So just go with the fair, and all the jobs will get fair amount of CPU or resources. Okay. And any questions so far? Okay, so that was about the yarn. Let's quickly talk a little bit about some of the advantages. Okay, let's quickly have a yeah, this one. So very quickly we'll just see what is the difference between these two. So in Hadoop 1, only MapReduce application can be processed, right, which was a very big limitation. But if you really see, in the last 2 years, most of the development which has happened in the Hadoop area, it has all happened in the non-MapReduce processing. So MapReduce has kind of become obsolete nowadays. Okay, everybody nowadays, they talk about real time, Spark, Storm, Kafka, a lot of these type of things. So a lot of things has been made possible only of the introduction of Yarn. right? And cluster resource management, like it was kind of everything was done by the job tracker, and in Hadoop 2 we have resource manager which takes care of the resource management. And cluster resources were not fully utilized because of the way the cluster resource was handled. Uh, it was not optimally utilized. So even though you had the resources, but we were not able to submit new tasks, right? But over here in the Hadoop, in the Yarn architecture, there has been an optimal utilization of the resources. Okay, and task tracker and the job tracker were responsible for execution. In Hadoop 2, there is nothing called task tracker or job tracker. Both of these has been removed and they have been replaced with resource manager, and there is this node manager. This so we have node manager which replaces the task tracker, and there is nothing called job tracker. So we, instead of job tracker, we have a resource manager. And there are some components like over here we are saying that there are some non-map reduced jobs right over here. So what are these non-map reduced job? Other data processing. So there are some new components like Tej. Okay, there is something known as HBase on Yarn, which is Hoya. Machine learning, Spark. Graph processing, Giraffe, real-time processing, Storm. So all of these things are the other data processing. They are not based on the MapReduce. Okay, but they can run on the same Hadoop cluster on which the MapReduce can also run. So that's the major difference.